Hey guys, chapter 11. There's only 4 sections in chapter 11, which we're going to work through this week. There'll be shorter assignments, and if you have any questions, please ask. So we're going to talk about circumference and arc length. So, talking about circles. We're going to use the formula for circumference. Hopefully you already know that. We're just going to use it. And then we're going to use the arc length to find measures, and we're going to solve some real life problems. So our vocabulary, we have circumference, which is the distance around a circle. So like perimeter is circumference, but it's a circle. Arc length is a part or a portion of the circumference of a circle. So it's just one little piece of the circumference, kind of like one side of a perimeter is part of the perimeter. Okay, our other vocab we're going to see today is circle, diameter, and radius. So remember, diameter is the full length across the circle. The radius is half of that, which is just from the center to the circle. The circumference of a circle is the distance around the circle, and it was found or discovered when mathematicians many years ago were using a polygon inscribed in a circle to find a proportion that they kept noticing. So they started with a square, and they had this diameter relates to the diagonal of a square. And when they took the measurement of the circle and divided it by this diagonal in the square, or the diameter of the circle, they noticed it was really close to this number, and they got more and more sides. So here they have a octagon here, an octagon. They did the same thing, and they noticed that this was getting closer to this number. They did it with more sides, and the number of the length around the circle and divided by that diameter was closer and closer to this number. So that's how they discovered pi. And if you have Amazon Prime, there's a series called Numbers, not the detective story, but like a documentary of numbers. And one of those episodes is on the number pi. Really good story if you want to do some background check on that. Okay, we're going to look at the circumference of a circle. So the formula they developed noticing this pattern was the circumference is equal to the pi times the diameter. Or we can change that diameter to 2 times the radius, and we rewrite it in this form, 2 pi r. Okay, find the circumference of a circle with a radius of 9 centimeters. So we're going to choose the formula. Since our problem says radius, we're going to choose the formula that has the radius in it. Plug in a radius of 9. So we can multiply 2 times 9, and we can make that an 18 pi. Now, some of your problems in Big Ideas will ask for answers in terms of pi. So your answer would be 18 pi. Sometimes they will ask for a rounded answer or an exact answer. So you're going to put in your calculator 18 pi. For those of you that have graphing calculators at home that have the special pi button, you can do 18 pi and hit an answer and round it. If you don't have a calculator that has the pi button, then you can use just 3.14, and you'll multiply 18 times 3.14, and we get 56.55 centimeters. And that would be the answer rounded. Okay, example 2. The radius of a circle with a circumference of 26 meters. So again, our problem says radius. We're going to choose the formula that has the radius in it. So circumference equals 2 pi r. We are given the circumference this time is 26. So we're going to plug in the 26 for the circumference equals 2 pi r. We want to solve for r, so we're going to divide by 2 to get 13. And then we have to divide by pi to get r by itself. So in terms of pi, our answer would be 13 divided by pi, or plug it in your calculator, 13 divided by pi, or 13 divided by 3.14, and we get approximately 4.14 meters. Now let's find the diameter of a circle with a circumference of 17 feet. This time our problem asks for the diameter, so we can use the formula that includes the diameter. Circumference equals pi diameter. So we are also given the circumference is 17, so we're going to plug in the 17 for the C. Now to solve for the diameter, we have to divide by pi. So our answer in terms of pi is 17 divided by pi, or the answer rounded would be 17 divided by 3.14, and we get 5.41 feet. All right, so arc length, it's a portion of the circumference of a circle. So it is a ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. In other words, the arc length of AB is equal to the measure of arc AB, which is talking about the degree of this arc. Okay, so we learned about central angles in the previous sections. Remember, our central angle is the same as the measure of the arc. So 360 is the total degrees of the circle. So we're taking the fraction of this circle and multiplying it by the 2 pi r, the circumference. All right, so here's an example. We're going to find the arc length of AB. Now we found the measure of the arcs in previous sections. Using the central angle, remember the measure of the arc is the same as the measure of this central angle. So this measure of the arc is 60, and we are given the radius here at 8 centimeters. Okay, so we're going to plug it into our formula for the measure of the arc length. Arc length is equal to 60 divided by 360. 2 pi, radius is 8. So let's reduce our fraction. 60 divided by 360 is 1/6. We're multiplying 2 times 8 to get 16. And then we can multiply 1/6 times 16, reduce your fraction, and you get 8/3 pi. So our answer in terms of pi is 8/3 pi. Or you can multiply all of this part in your calculator. 1 divided by 6 times 16 times pi, or 3.14, and you get 8.38 centimeters. Okay, example 5. We're given the arc length, and I know this is the arc length and not the measure of the arc because it's meters and not degrees. Okay, but the central angle here is 270 degrees. So the measure of this arc is 270 degrees. We want to find the circumference of circle N. Remember, the circumference is 2 pi r. And we don't know the radius, but that's okay because we just want to find the circumference. Excuse me. So our formula is the arc length. 61.26 is our arc length. The measure of our arc LM is 270 degrees. And this 2 pi r is the circumference. So we're solving for 2 pi r. Okay, so let's reduce our fraction. 270 divided by 360, they're both divisible by 90, which gives us the 3/4. And to get rid of this 3/4, we want to multiply by the reciprocal to cancel our fraction. So our cross cancellation will cancel this fraction, but we have to multiply 61.26 times 4/3 to get 81.68 equals, bring down the 2 pi r. Now, we want to find the circumference. The circumference is 2 pi r. So we solved for 2 pi r. This is the circumference, and that's our final answer, 81.68 meters. Okay, now this time we want to find the radius of circle G. We're given the arc length, and we're given the central angle. So we're given the measure of the arc. Okay, so let's plug into our formula. The arc length is 10.5, goes here, and the measure of arc EF. Arc EF is the same as the central angle, so it's 150. Okay, so I want to solve for the radius this time, not 2 pi r. So I'm going to go ahead, just to make things a little bit more simple, I'm going to go ahead and multiply the 2 times 150 to make that 300 over 360. And then reduce the fraction, both divisible by 60. So we get 5/6 times pi r, and we want to cancel our fraction. So we're going to multiply by the reciprocal. So we're multiplying by 6/5 to cancel this here, but we multiply 10.5 times 6/5, and we get 12.6 equals, bring down the pi r. We want to solve for the radius. So now, very last step is to divide by pi, and that's always our very last step at multiplying or dividing by pi. That's very important because you might get rounding errors if you don't do it that way. Okay, so our answer in terms of pi would be 12.6 over pi, or we can divide 12.6 divided by 3.14, and we get approximately 4.01 feet. All right, so real life problems. Tires. Everybody's interested in tires when we're driving, right? And we all go places in cars, and we like to measure how far we drive, and we like to measure different parts of the tires to tell us how fast we go, and all sorts of different measurements can be used on these tires, right? So here we have the dimensions of our car tire, and when we want to know to the nearest foot how far does the tire travel in 15 revolutions. So if I spin the tire 15 times, roll it 15 times all the way completely around, how far would that go? So one revolution is the circumference. That's what I deleted that. So our circumference is the circumference equals pi times diameter. And the diameter of our tire, we had the 5.5 on the top and on the bottom where the rubber was, and the rim of the wheel, I guess, what is it called? The wheel, I guess, was 15. So if we add all of those up together, we get 26 inches, and that's going to be the diameter of our tire. So the circumference is 26 pi. And our distance, we're going to do 15 revolutions. So we do 15 times the circumference to get 390 pi in terms of pi. Now, usually when we talk in distance, we want feet, not inches, right? So we could multiply by 3.14 to get our total inches, but we don't like inches. So let's convert it to feet, see how far we can go in feet. And so I want to avoid rounding errors, which means I'm going to do the conversions first. Okay. So there is 1 foot in 12 inches, 12 inches in 1 foot. So inches and inches will cancel if I set it up in this fraction form here. I got 1 foot on top. And I get 390 pi divided by 12. So there's our answer in terms of pi. The last step I want to take is doing that multiplication with pi to avoid my rounding errors. So I do 390 times pi divided by 12. And I get my final answer of 102 feet, approximately, because it said round to the nearest foot. All right, all the track stars here. Everybody knows if you run on the inside path, you don't run as far as you do if you ran on the outside path, right? So here is a track. The curves of the track are 180-degree arcs. So they're semicircles, right? The radius of the arc for a runner on the red track, the inside track, is this 36.8 meters. And we want to know about how far does the athlete run in one lap around the track. So if I use the inside track, how far am I going? So if I run this curve, it's 180 degrees. And if I run this curve, it's 180 degrees. So if I run both curves, which I would do in one lap, I'm running one complete circle, right? And then I'm also running both straight sides. So I'm running 2 straight sides here. All right, so I have one circumference because of the one circle, both of these semicircles put together, plus 2 straights. So 2 pi radius of our inside track was the 36.8. My 2 straights was 84.39. So multiply 2 pi, you can put all of this in your calculator together at one time, or you can multiply them separately. To get our total lap length is approximately 400 meters, which is why in track we have the 400-meter event. And we call one lap 400 meters. You ran on the outside lane, you add 45 meters on there. All right, guys. I hope you have a great day. If you have any questions, please ask, and I look forward to hearing from you guys.